Dear students, last time I started explaining you what is a Boolean logic and have shown you some examples related to Boolean logic. So now I would like to again remind you what is a set. Set, I think, is a very, very important concept in the field of mathematics. So without understanding sets, I think it's hard to understand actually the function theory, which is also one of the parts of mathematics. So please check out this Wikipedia page. So also I have given you another page related to Boolean logic. So if you have sets, you can do some operation with sets. Some of the operations are actually mentioned here. For example, here we have intersection of two sets. So this is called intersection. So we intersect two sets. So intersection of two sets. And actually, if you use this intersection symbol, so it's shown like here. So this would be the intersection of sets A and B. All right. Okay. So also, I think it's a very important term, actually phrase. Boolean related to Boolean logic is a truth table. So I will return to truth tables a bit later. Today I will give you some examples of how they are working. Okay, so let's return to my presentation. So if you have two sets of shoes, so the first set and second set, and means the intersection. Or here means union. So first set and second set. So the elements of a set, So we have elements of the first set and elements of the second set, right? So we consider them all in the case if you use OR function. Again, OR is the function which we will study today. Also, we have not converts to opposite. For example, not true is obviously false, right? So let's say if you have true, right? True. So if you apply not, so you will get false, right? False. And obviously, so not false will be equal to what? To true, right? So it will convert the false to opposite, right? So we have only two things here, true or false. So false is what? Is 0 or 1? False is 0, right? True is 1. So I'm talking about binary logic, right? Binary logic. Binary logic is based on binary system. Binary system or binary number system. Such kind of phrase is also possible. Binary number system. So dear students, please don't forget that so two important functions here are AND and OR, right? Also not. But we have more Boolean functions, but I think it would be better if you focus on AND, OR, and NOT functions. Let me show you a better example from which you can understand how this function work. Okay, AND function. So let's say we have two guys, two men A and man B, right? You can consider them as a set of elements, like a tie, some kind of mustaches, then let's say some hair here, right? A and B. So if you apply A and B, so it will refer to some common things which A and B have. For example, look here. This is result of using AND operation. So A and B. So the first guy has this part, right? This part also here, and also this part of here, also here, right? The second guy has this one, right? Here, right? Until here, I think. Also has this one, right? Until here. And also this part of here also exists. So this is the intersection. Again, look here. We just found what they have in common. What these guys have in common. It means we need to find those things so which belong to guy A and also belong to guy B, right? So, or everything should be included from the first set and the second set. So let's check the Boolean here logic. So we just put everything from here to here, and we put everything from this guy to here. So as a result, so this guy has full hair. So this part is from this guy right here. Then this guy has beard and mustaches. Okay, so we bring it here, right? So everything is included here. Both of them have this part of hair, so also is included. So everything is mixed. This is the operation called so A or B, right? Or function. Also we have XOR function, but we will not focus on it. So we will mostly discuss AND and OR and NOT function. But I will also give you some examples of XOR function. Again, this is a good example for Boolean here logic. So the next. So we need to now understand what is a truth table. Truth table is also an important concept in Boolean algebra. First of all, I think I recommend you to check out the current web page about Boolean, about truth table. So moreover, you can simply use a neighbor and find more clear explanation about Boolean table, about truth table. Okay, so please look here. So in this Boolean, in a truth table, I use what kind of things? Not, or, and AND. So in Excel, we use them in such a way. We simply type not. This is not function, or is or function, and is and function. Okay. In maths, we use different symbols. This is for not, this is for or, and this is for and. Okay. Okay. So, but you don't need to know this. Please look at this table. So let's say I have two inputs. What kind of inputs? So they are shown here. So I have input A and I have input B. Okay. So for example, A is equal to false, B is equal to false. A and B will return false. A or B will return false. So if you have false and true, A and B, or false and true will return false. True and false will return false for AND function, right? Yet if you have true and true, then true and true will return true, right? So please look here. So true will be returned if both A and B are true, right? So in this case, so we have true here, we have true here, and also A and B will be true if both of inputs are equal to true, right? In the case if you have a minimum one false, right, you may have one false, like here or here. Also you have one false. Here you have two falses. The result will be false. So now let's check on the OR function. OR function. The first case, false or false. For false or false will return false. False or true will return true. True or false will return true. True or true will return true. So in three cases we have true, right? And only in one case we have false, right? If both of the inputs are false, we have false, right? So if you have one true here, it will return true, right? If we have two truths, we have also true here. So this is a special case here. So false or false will give you false. And not A means opposite of A. So we have in binary system, we have only two digits. We have 0 and 1, right? Or false and true, right? So A is given here. So A is what? A is false, right? A is false. So not false will give you true, right? Not false. Not false will give you again true. Not true will give you the opposite, false, and not true will also give you false. So a truth table is a mathematical table used in logic, specifically in connection with Boolean algebra. So if you don't understand the logic here, I suggest you to memorize this table. So the name of this table is truth table. So we can easily generate this table. I think we will do this a bit later. So usually in textbooks or somewhere in the internet or any other books or videos, so they show truth table in this form. So if you don't understand the logic, I think it will be hard to understand the concept of Boolean functions. Therefore, I decided to develop some simple example related to the truth table. So you will not find this example anywhere in the internet or somewhere in a textbook. So I have created this so that my students can better understand the concept of a truth table. Okay, so now let's consider two inputs. So what kind of inputs they are? Input A and B, okay? Instead of true and false, I'm using some sentences here. So now is a weekday, right? So we usually study in weekdays. What kind of weekdays do we have? Let's say, okay, so firstly I will clarify. So we have a weekday, day, right? So we have what? Monday, we have Tuesday, and until Friday, okay? Until Friday. Also, we have weekend. What kind of days are included in the weekend? Saturday and Sunday. So we have 5 days for weekdays and only 2 days for weekend, right? Only 2 days. So if you understand this concept of weekday and weekend, then I think you can understand the example of my truth table. All right, so now let's return to the examples. I will again emphasize the inputs here. I have input A and B. So today is Saturday. Today is Saturday. So this is just a sentence. Of course, today is not Saturday, so you can understand that this is what? Is true or false? So today is not Saturday, so it means it's false. For false, I will use F, okay? F is not a grade here. F means some bad grade, right? But here is false. F is false, right? And T is true. Then it's dark outside. It's dark outside. If it's dark outside, then you can see it's dark, right? But now it's not dark outside, so it's also false. Okay, false. So, okay, now let's try to combine these sentences by using AND function. We will use AND function first. So today is Saturday and it's dark outside. So this sentence is what? Today is Saturday and it's dark outside. Is correct or wrong? Of course it's wrong, so you can say it's false, right? F, false. Then, today is Saturday. Today is Saturday is false statement, right? It's daylight outside. Daylight means so there is some light, right? So it's correct, right? So it's true. So then we will combine it. So by using AND word. Today is Saturday and it's daylight outside. So is it correct or false? So this sentence is false, right? Because today is not Saturday. So you can write F. False. Then, it's a weekday today. It's a weekday. You know that today is a weekday. So it means it's true, right? It's dark outside. Now it's not dark. I can see a sky. So it's false. So now let's combine these two sentences. It's a weekday today and dark outside. So is it a correct sentence or wrong sentence? It's a weekday today and it's dark outside. It's a wrong sentence because it's not dark outside. So F, false. It's a weekday today. It's a weekday today. This is true, right? Today is a weekday. Today is not Saturday or Sunday. It's daylight outside. So it means you can see some light, right? It's not dark. It's true, right? If we combine, we will get the following. Today is a weekday and it's daylight outside. So both of them are correct. So you can say that this sentence is fully correct. So it's true, okay? Now for, let's do this for not A first. So today is Saturday. We need to make it opposite. Today is not Saturday. Today is not Saturday. Is it true or wrong? It's true. So you can write T here. T means true. The next one, same. Today is not Saturday. True, right? The next one is it's a weekday today. A. Okay? Look at the A, please. Because we compute not A. Also, we can compute not B, but I think one would be enough here. So it's a weekday today. It's not a weekday today. Today is weekday, so it's a false statement. Okay. So next one, it's a weekday today. The same. So again, it's not a weekday. It's a weekend today. So it's not a weekday. So it means it's a weekend, right? But this is false. Today is not a weekend. Today is not weekend. So not weekday means a weekend, right? I hope you understand the concept here. So now let's consider OR function. So this is AND function, okay? AND function, and this is OR function. So we have two inputs, A and B. So, but now we use OR in this sentence. Today is Saturday or it's dark outside. So today is Saturday. Today is not Saturday. It's dark outside. None of these are working, so it's false. Then, what else here? Today is Saturday or it's daylight outside. Today is not Saturday, but today is daylight, right? It's daylight outside. So you can say that this is true, because one of these statements is true. It's a weekday today or dark outside. So it's not dark outside, but it's a weekday today. So it's true also. And today is a weekday or it's daylight outside. So today is a weekday and it's daylight. So both of them are true. So by using such simple examples, I can explain in a simple way how to construct a truth table. All right, so now let's start discussing these functions and how they work in Microsoft Excel. Dear students, don't forget that all functions should be starting by equal sign. This is equal sign, okay? Equal sign. If you don't write equal sign, if you don't use it, then you cannot compute it. So, and function returns true if all its arguments evaluate to true. It returns false if one or more arguments evaluate to false. So we can test it. So here, first of all, you need to write the function itself, right? Then we will have some arguments here. Arguments are separated by comma, right? Don't forget, we can use up to 256 arguments. And at the end of the line, you need to use parentheses. Only then you can press enter button, okay? So on the next page, I will show you some examples. Okay, here we are. So two examples. Let's say we have two truths, right? And we want to apply AND function. So we start with typing AND, then true and true. So all arguments are true, so the result will be true. The next example, AND, so two arguments, true and false. One argument is false, then the result is false. You can also check this in the truth table, which I have shown to you. So I suggest you to understand or to memorize this truth table. So now let's try to test it together. I will use AND function. But first of all, we need to have some what? We need to have some logical expressions. Let's say I will input two expressions in A1 and B1. Okay, the first one, let's say 10 is greater than 1. So I want to test this logical expression. Obviously, you understand that 10 is greater than 1, so what would be the result here? The result will be true. Now, let me input another logical expression equal, let's say 10 is not equal to 10. 10 is not equal to 10, and we will have false here. Why? Because 10 is equal to 10, but I'm writing that 10 is not equal to 10. So this means not equal, not equal. Okay, so now we have two inputs, true and false. So now let me compute the AND function, how AND function will work. Firstly, I'll just write it by text here. Then equal, don't forget, AND A and D, and in parentheses I will input these arguments as A2, don't forget comma, then B2. And then I have to close the parentheses and enter. So result will be false. So true and false will result in false. true and false, and the result is false. Why? Because one of the arguments is false. Okay, the next one, let me now make it true and true. I'll modify here. Let's say 10 is larger than minus 10. So 10 is greater than minus 10. This is clear. Why? Because 10 is a positive number, so with plus sign, and minus 10 is a negative number with minus sign. So it should be true now. So true, and AND function will return true. So by using such approach, you can compute the result for actually not only for two things here, not only for two arguments, but also you can include more. For example, you can use comma here, you can input some other arguments, so which is also possible. Don't forget, if you use commas, then the maximum number of arguments is equal to 256. So this is what I wanted to tell you about AND function. So if you don't understand it, I suggest you to use this tool, insert function. So here you will type AND function. You will set AND function. So, or you can just find actually logical functions here, AND, right? AND function. So it checks whether all arguments are true and returns true if all arguments are true. So if you don't understand it, I suggest you to check the help on this function, so you can find more complex examples so that you can better understand the concept. Again, insert function. Okay, then you can access to help related to this function. Okay, the next function is called OR function. Use the OR function, one of the logical functions, to return a true if any argument is true, and also it returns false if all arguments are false. The syntax of this function is actually similar to the AND function. We start with equal sign. We'll start with the equal sign, right? Then write OR function, and we should have some arguments here. If you use this argument, so this is compulsory argument, then you can use 255 arguments more, right? So 255 plus 1 will give you 256. So now let's consider some examples related to OR function. For example, please look here. So instead of using true and false here, I directly use some logical expressions here. So this is a logical expression. Okay, this one and this one, they are logical expressions. Okay, so actually by writing this, I can test if it's true or false. Also, you can do this by yourself, because you understand that 1 plus 1 is equal to what? Is not equal to 1, is equal to 2, right? So this is false, this is false, and 2 plus 2 is equal to 4, is not equal to 5, right? Is also false. So this logical expression is false, or false, false or false will return what? Also false. And you can check this in our truth table. So if you return to truth table, so false or false will give you what? False or false will return false. So this is shown here. So the next example here, we have 3 inputs. Since at least one argument is equal to true, right? So the result will be true. So here the first is true, others are false, but at least one argument is true, then the result will be true. So now let's do some computations in Microsoft Excel. Again, and or function. Okay, so first of all, let me write it here, or I'll use it here as a text. Okay, here equal, then or function, parenthesis, A2, comma, B2, right? Then closing the parenthesis. Enter. Okay, so you have through here. If you have false here, let's say not equal 10 is not equal to 10 is a false, then you will have so true or false will return true. So in the same way we can actually continue. We can compute through or through and through here, and we can generate truth table by using these functions here. So also we can try to do in this way. So for example, equal, and I will try true, right, and see if it works, and comma, true. Okay. Oh, sorry, I didn't use comma here. Comma. Let's see if it works. Okay, it returns true, right? If we use false here, so it will return false. So it will also work in this way. So we can simply add something here, for example, true, and true, and also true. Then copy this formula here. Copy this formula here. For example, false, then false here, and then we can copy it here. So you will get a truth table by simply using these functions and or function. The next one, not function, not. It reverses, so I think you don't know what is to reverse. Reverse, so it means it changes to opposite. It reverses the value of its argument. So please look here at this example. We have a logical expression here. We have only one argument. So 1 plus 1 is what? Is 2. 2 is equal to 2, right? Is it correct or wrong? Of course, this is correct. So we can say that this is true, right? True. And not true will reverse it, and as a result we will have false. So I suggest also to include not to our table. Don't forget, we have to use equal sign also here. So let's compute not A. What is not A? Let's say I will use one-time formula here, equal not, then opening parenthesis, and A is here, okay? Okay, then we'll close parenthesis. Okay, as a result you have false. A, this is B. Okay, all right, false. Not A is not true is false. So to compute other cells, I will simply copy the formula. So I have used relative reference here. So therefore, when you copy it to another cell, so A2 will become A3, right? Then it will become A4. So this is advantage of using relative references. Again, don't forget, so we use relative references, and also we have absolute references. So if you use absolute references, you can just, let's say, I will give you an example, use a dollar sign like $1, right? So if you copy this formula to any other cell, it will not change. So it will be the absolute. The next function is known as XOR function, or you can read it as XOR function. It returns a logical exclusive OR of all arguments. So the syntax of all these functions are exactly the same. I mean, AND function and OR function and XOR function have exactly the same syntax. So let's consider the following example. So equal XOR, here we have two logical expressions. What kind of logical expressions do we have here? So the first one is 3 is greater than 12. So is it true or false? Of course, 3 is less than 12, so you can say that this is what? This is false, right? This is false. And 4 is what? Is greater than 6 is also false, right? So it's not correct. Because all test results evaluate to false, false is returned. At least one of the test results must evaluate to true to return true. So now let's check it in Excel. I will return to my worksheet. And let me search XOR here, XOR. You can see there is a function which is known as XOR, which returns a logical exclusive OR of all given arguments. Parenthesis, and what? I need to have two inputs, A, comma, B, right? Then closing parenthesis, and finally I need to use enter here. Okay, enter. Okay, the result is true, right? XOR. So let's now copy it to another cells, and we will see another cells here. So XOR of A true and false is true, true and true is false, right? And what else? False, XOR false is also false. Nested Boolean functions. There are some common combinations that are useful to know. For example, first of all, I will apply AND function to A and B, right? And then I want to apply NOT. So I want to reverse it. As you can see from here, so I use two functions. So one function is nested into another function. The same here. OR function is nested into NOT function. So of course, we don't have functions which are called NAND or NAR in Excel. This is just a logic. We don't have such functions in Excel. You can actually try to look for such functions, but you won't find them in Excel, okay? Excel doesn't have them, but you can use nested formulas or nested functions. I think I already explained to you the meaning of nested functions, and you can check our previous videos. Now, dear students, I suggest you to open page 77 of an exercise 2 of our textbook. So I suggest you to stop the video now and open the textbook. So you will find such a table. So this kind of functions can be used in quality control. Quality control. Quality control is an important field, especially for industrial engineers. So industrial engineers, they have to understand what is quality control, and they need to use spatial methods how they can apply various tests. Okay, so let me find page 77. Okay, so let me read this exercise number 2. So the scenario for this exercise is as follows. In a manufacturing plant, 10 items are tested every hour. So let's say 10 products are tested, okay, 10 products. So for each item, or you can say item, right? For each item, 2 quantities, so we have P and Q, are measured. So these numbers are for P and Q are given. So the p-value must be at least a certain value. So it should be at least the given certain value, which is 1.25, okay? While the q value must not exceed a certain value, q max. So q max should not be higher than 0.5. So if it will be equal to 0.6, then it's not good for us. So you can actually find the screenshot from this page on actually my PowerPoint presentation, or you can find it in here. So values P and Q are given. So also what is good in exercises in this textbook, so they have actually very detailed solutions. So that means if you look in the solution, so there will be several steps. They will start with explaining. So step A. So on the worksheet, blah, 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 enter the text and etc. So I suggest you to follow these instructions. Dear students, don't forget. So this textbook is very good and interesting, but it sometimes has some small typos. It means some small errors are found. It's not bad. It's good because students usually try finding these errors or typos. They understand that this is an error or typo. So here, so P and Q values are given. So we have 10 measurements, right? 10 measurements. So 1, 2, 3, 4 until 10, right? So we should have 2 tests. 2 tests. The first test is known as p-test. P-test. So what do we need to do? So let's click here. So there is a formula. There is a formula. So it says that what? Actually the problem statement, so they say that the p-value must be at least a certain value. So this is p minimum, okay? P minimum is given. So we have to compare this value with all these values, okay? So for example here, 1.7. So it's higher than minimum, right? It means that's okay. It's fine for us. It's true. It's true, right? So instead of true, we have 1 here. So we can use such kind of signs, as you can see from here, minus signs. So double negation. We call this double negation. Double negation. 2 minuses. Minus and again minus. So for this item, so p test is okay, it's passed. So this value is higher than p minimum, right? The next one, 1.36 is what? Is higher than 1.25. Then 144 is okay. The next one is okay. 1.9 is higher. It means okay, is through, right? Then what? 152, 123 is what? 123 is lower. So p-test has been failed. So instead of writing fail or false, we want to write 0. Okay? Don't forget, I will use these formulas, and as you can see here, I will assign some name to this cell. So this cell is p minimum here. So in last classes, I have told you how to give names. So you will select a cell, then here you will write name in a name box, right? We have p minimum. If you don't want to do this, you can simply write C2. This is also possible. So then the next value is okay, is larger, and this one is also failed, right? So here we need to input formula only one time, only once here, press enter, then you will just simply copy it here. You will copy, and then you will compute the percentage of passing here. So we have 10 items, right? So how many items passed p-test? 1, 2, 3, 4, 5, 6, 7, and 8. 8 of 10 means percentage passing is 80%. So I have computed this by using sum and count functions. So please check it out. I will share you with the file. Then Q-test. So this is the second test. So we will compare with Q, right? For example, the first item, 1.7. 1.7 is higher than 0.5, right? Is higher than 0.5. 0.5 is Q max here. So it's higher. It means Q-test failed. Then 1.36. 1.36 what? 1.36 is what? 1. Q max. So, yeah, not 1.7, 0.65. We compare Q here, right? So, Q, 0.65 is higher, so it means failed here. 0.5 is okay. Fine. 0.4 less than this value, okay. 0.45 is also okay. Then 0.82 too high, higher than 0.5, it means failed, and etc. So here we'll just write it once and we can copy the formula. Then what is the most important? So we need to check what kind of items have passed both of two tests. Because if item has failed one test, it means it's totally failed, right? For example, here, p-test is okay, fine, q-test failed, right? So generally speaking, so it's failure, right? We will have 0 here. If passed p-test, then passed q-test, then two tests are okay, fine. One is fine, it means one is passed and 0 has failed. The same here, 1, 1, 1, 1, 1, 1. So p-test has passed, q-test failed. As a result, is failed, right? The item failed. So we can compute this by applying AND function. So we will use AND function here, okay? AND function. So if you don't want to use double negation, you can multiply it by 1. So which is also, I think, possible. So after you type it, then you will simply copy, right? So usually in all examples in this textbook, you will find very detailed explanations. So for example, for E6, we should use this formula. If you don't want to use double negation as shown in this textbook, then I suggest you to multiply it by 1. So I have already modified the formula, and instead of using double negation like here, right, I have multiplied it by 1. So I don't want to see any text like true or false. Instead, I want to see numbers because it's easier to compute percentage passing after. Okay, so 1, enter, and then you will simply copy the formula. So now, for the p-test we have 80% of passing. For q-test we have 70. It means 7 times, right? 7 items have passed the test. And for combined tests, right, for 2 tests, how many percents do we have? 1, 2, 3, 4, 5, 6. We have 6 items. 6 items of given 10. It means percentage of passing is only 60. So 60 items passed the quality control test. So on practice, we can apply more tests, not only P and Q. We can use first test, second test, the third test, and we will use AND function if it's, of course, necessary. The next function we will discuss today is if function. So if function is very interesting, but at the same time is more complex. Also, we can use nested if functions, and formulas will become more and more complex. So please look at this flowchart. So engineers usually use flowcharts, right, to understand and explain something. So if so there is a statement, right? We want to check if it's true or false, right? If it's true, we go to here, to B, right? If it's false, we go to C. So, and then we can continue to other, things. If function. So it returns one of 2 values depending on the truth value of a logical expression called the test. So this is the syntax. Syntax is very important. So the syntax is different than AND function, than OR function, or XOR function, or NOT function. So the syntax is more complex. So I think you understand what is a syntax, function, syntax. Okay. All right, function syntax. So first of all, we should have a logical test. Logical test. So if the test is true, then whatever is entered as true value gets returned. Otherwise, if it's not true, otherwise false value gets returned. So let me show you some example so you will better understand how it works. So cell A1. So we have to keep some number in cell A1. So and then a logical test must return either true or false, as you already know. So we have only 2 outputs here, true or false. If you multiply the formula by 1, then you can, let's say, return 1 or 0, right? So if you type in this way, so A1 greater than 10 multiplied by 1, so you can return 1 or 0 depending on the value of A1. So I think you also already know this. So now let's do a very simple example. So I will store some number in a cell A1 and use this formula. So I want to compare, so this one will be what? This one will what? My logical test. This is the first argument, right? The first argument is a logical test. A1 is greater or equal to 10. So then, the value if this is true. So if A1 value is greater or equal to 10, then is okay. If otherwise, it's too small, okay? So let's try to input this together. So let me return to Excel. And I will create a new page, I think. Okay, new book is okay also. Okay, let me keep some number here. Let's say 15, okay? Here I will use formula related to if. If, okay, if what? If A1 is, let's say, larger than 10, right? You can see some hints here. Even Excel is giving some hints to you. So this is the logical test, right? Logical test. Then, comma, value if true. What is value if true? So let's say, okay. So if you use text, dear students, don't forget to use apostrophe here. Okay. Then close it. Then comma. Then comma, and again use apostrophe here, small or too small. All right. So don't forget to close the parentheses, and we will press enter at the end of this line. Okay, so it returns okay. So 15 is larger than 10, is greater than 10, right? Is greater than 10. If it's true, then okay. So now let's modify it. Let's say 5. 5 is less than 10, right? So the result should be what? Too small. So based on the input, output will change, right? Output will change. So by using only one if function without nesting, you can return two values, true or false. Of course, you can replace true with okay, right? Or some other text. So you can type this here. So instead of false, you can write something else. For example, too small or bad or unnecessary. So whatever you want. So this is how if function works. Other examples are here. I will not input this. So let's say the text negative if A2 cell has a value less than 0. So negative means not bad, but it means negative number. Negative number. For example, -1, -3, -10 are negative numbers. So, for example, if I input -2 in A2 cell, then -2 will be less than 0, right? It means if true, then I should have negative number. If false, I need to have positive number. Okay. Another example. So here, this is my logical expression. So we compute sum, right? And if sum of numbers in these cells, right, from A12 to A20 is greater than 0, then we will return the sum itself. But if it's less than 0, then it will be written error. Okay? So we can return not only text, right, but also we can return some value, which is also, value means number value, which is also possible here. But again, don't forget, so if function, if it's not nested, it has 3 arguments. So the first argument is here, right? A logical expression. Then value if true, right, and otherwise if wrong. So 3 arguments are also used here. Another example. So in another example, they use nested if. Nested if. So I think I will also try to implement it. But first of all, let me show you this, right? So there is a number in A1 cell. But instead of returning big or small, we want to return several things. Like big, average, medium means average, medium, or average, and small. For example, it's very useful when we classify, for example, the height of a person. Height of a person, right? Or mass of a person, or for example, or mass of an engine, right? Mass of an engine. So some engines are small, right? Especially small cars, they have small engines, maybe 1 liter volume. Average cars, they have, for instance, from 1 to 1 or to 2 liters. And trucks may have very high volume engines. So, and such kind of function, which is called nested if function. So why it's nested? Because we use it 2 times here. So we place one if function inside another function. So it's nested function. Nested function. Nested function. So one function is placed another function. Again, nest is a home of birds. I already told you. So let's say you have if function, right, with arguments here. Inside this function, we have another if function. We have another if function, okay? So this is nested if function. So now let me copy this formula and I will try to show you in my worksheet. So in cell A1, I store a number which is equal to 5. In cell A2, I will input the formula. So where I have nested ifs, as you can see here. So I have 2 if functions. So one function is nested inside another function. So all right. Now let me use enter here, and there is a mistake, right? This often happens. You need to carefully edit your formulas. So why there is a mistake? First of all, let's check it. So where is the mistake here? Everything is okay. So this is logical expression, right? Then this is a value if what? If true, right? A1, again, logical expression, big. And here, now let me replace these apostrophes with this one. No, with this one. Okay. This one. And here is this one, and this one, and this one, and this one. All right. Now it should work. Now it's small, right? So we compare with 10 and 50. 10 and 50. So let me write some, I will use some scale. Let's say 10, right? We have 10. Then we have 50 here. 50, okay? So, what we have here, we have what kind of engine? We have a big engine, right? Big engine. Then we have a medium here. We have medium. And we have what? We have small, right? Small. So using nested function, we can classify, right, based on the input value. So obviously, if 5 is less than 10, right, then it's small, right? Small engine. If from 10 to 50, medium, and if higher than 50, then is a big, okay? Let's do this. Instead of 5, let me input something here. let's say 20. Okay, it turns to medium, as you can see here, medium. Let me put some number which is larger than 50. Let's say 60. Okay, as a result, you have big here, as shown here. Let me input negative, minus 10, small. So also negative numbers are included here. So in this formula, negative numbers are included. You can exclude them, but again, you need to use some other functions here. So the function will become more and more complex. So more nested functions you use, the more complex things you can do and you can compute. The next functions are called table lookup functions. They are more complex, so we will not do any serious problems, any serious examples related to table lookup functions. I will show you only one function, how it works. So table lookup functions have a range of uses. So they are very nice if you work with large and big data sets. So whenever you find yourself creating a multi-nested if function, instead of this, you can consider whether a lookup function would be more appropriate. So as I told you before, you can use nested if functions, but such functions are more complex. Instead of them, we can use table lookup functions. So we have mainly we have vertical table lookup functions and horizontal lookup functions. So these functions have similar syntax. So they are named VLOOKUP and HLOOKUP. VLOOKUP and HLOOKUP. So please look here. We have one argument, the second argument, the third argument, the fourth argument. Okay, the same arguments, only function names are different. So first argument is lookup value, is the value to be located in the first column of a vertical table or the first row of a horizontal table, based on what function you use, HLOOKUP or VLOOKUP function. So lookup value may be either a numerical or text value or a cell reference. So you can use a number, you can use a text, or you can use cell reference, for example, AB, A1, for example, or B1. So this is a cell reference. So then we have another argument, table array. Table array is the second argument here. The second is the range reference or name of the table. So you can select your table, right? The next one, column index number or row index number, is the column or row of the table from which the value is to be returned. So you will select, for example, the third column or the second row or the fifth row. Then range lookup is a logical value, true or false, specifying whether you want an approximate or exact match. So match can be approximate, match, or exact match. So for example, if you're looking some numbers, you may not find what you are looking for. For example, you look for 5.1, but in table there is no 5.1. So you can apply approximate match. Instead of 5.1, you may find, for example, 5.2, right, or 4.9. So if a range lookup is true or omitted, and there is no exact match, then the function returns the next largest value that is less than the lookup value. So if false and no exact match is found, the function will return the error value. So this is error value, as you remember. If lookup value is less than the lowest value in the first column or first row with HLOOKUP function, the function returns the NAR value. So if you're interested in HLOOKUP and VLOOK functions, so please watch the following video tutorial. So you won't have any exercises related to VLOOKUP and HLOOKUP function. So another function is also very interesting. It's called match function. Match function. So it searches for a specified item in a range of cells and then returns the relative position of that item in the range. So this is the syntax of this function. Don't forget to use equal sign, match, lookup value, and then lookup array, right? And match type is optional. You can input numbers -1, 0, or 1. So this argument specifies how Excel matches lookup value with values in a lookup array. So the default value for this argument is 1. So if you don't use it, so automatically it will be 1. So it's optional. Okay, these two are, so you have to use these arguments. One simple example. So let's say you have a range of numbers from A1 to A3. So let's say you have you have 3 values. Okay, this is column A, right? So you have A1, A2, A3, right? So we have 5. Then what we have 25, and we have 38. So then you use match function 25. You look for 25. So you want to find where is 25 here in the lookup range A1, A3, right? From A1 to A3. So it returns the number 2 because 25 is in the second item in this range, the second one. 1, 2, 3, right? So we have the second is 25. Excel has more interesting functions which are used for so-called conditional arithmetic. Conditional arithmetic. So functions such as SUMIF, as you can see here, so we combine two functions. So we have sum function, right, for adding numbers, and we add if to here, right, sum and if. So it's written together. Or COUNTIF. We have count function and we add if. And average if, also we have average function to compute the average of given numbers, and we add if here. So they may be used to conditionally sum or add, right, count, or finding average values subject to a specified criterion being satisfied. So that means we should have some criterion. One criterion and so 2 criteria, okay? Criteria. So here we'll have 1 criterion, and also if you use more than 1 criterion, for example 2 or 3, then you will write these functions as shown here, like SUMIFs. Instead of if, we have ifs. It means we use several criteria, right? COUNTIFs and average ifs. So now let me show you some simple examples. So SUMIF function, you can use it to sum the values in a range of cells which meet criteria that you specify. For example, suppose that in a column that contains numbers, you want to add plus, right, only the values that are larger than 5. So you can use the following formula. Again, equal SUMIF range B2 to B25, and you want to add only numbers which are higher than 5. So you don't want to have other numbers. So let's test it together. I think I will return here and create new page. Okay, let's say I have some numbers like I'll use let's say negative numbers and positive numbers. So let's say -1, -3, 5, 6, -4, 5, and 2. All right. So I have a range of cells or range of numbers, or you can say set of numbers, right? But I want to add only positive numbers. So what does it mean? Positive with plus sign. This one, and this one. 6 plus 5 plus 2, right? I want to compute by using SUMIFS function. I will use a SUMIF function, right? SUMIF. I have only one criteria, only positive, but sometimes I may use SUMIFS function if I have more than one criterion. Okay, so now let's input this function. I will use it here. SUMIF, then parentheses, then Excel helps me. It says please input the range. What is the range here? The range is A1 to A6, right? Then criteria. Criteria is what? Larger than what? 0. Larger than 0. I don't want to use 0, only positive numbers. Then closing the apostrophe, parentheses, and what? Enter. That's all. So the sum is 13. 6 plus 5 is 11. 11 plus 2 will give you 13. So the answer is 13 here. So this is how SUMIF function works. In the same way, you can use average if function and COUNTIF function. So it's kind of simple. So if you have more than one criterion, if you have multiple criteria, multiple criteria, for example, positive numbers and only odd numbers, let's say. So you consider only positive numbers and odd numbers. You want to add odd numbers which are positive. So here we have two criteria. So you will follow the following syntax. So instead of SUMIF function, you will use SUMIFS function. So don't forget about S here. So these functions are very, very useful. Here, I just would like to demonstrate some examples. So for example, you would use sums to sum the number of retailers in the country who reside in a single zip code, and second criterion is whose profits exceed a specific value. Okay, so you input a range, right, and then define two criteria here. So therefore you have to add S here. This is SUMIFS. Also you can use average ifs and COUNTIFs functions. And finally, dear students, I would like to explain you what is a conditional formatting. Actually, you can find this in the Home tab, and here we have conditional formatting. It's a very interesting tool for data visualization. Data visualization. As you know, data visualization is a very, very important skill for nowadays engineers. So if you want to be a successful engineer, then you need to learn data visualization. You need to know how to work with data. So here we can use different colors. We can use data bars and icons also. Moreover, you can define a new rule or apply existing one. Again, Home tab and conditional formatting. So let me open my Excel file here and I'll delete this. Okay, let's say I have these numbers. So Home tab here, okay. Then here we have what? Conditional formatting is here. Conditional formatting. So now let me select the range of numbers here. Then conditional formatting. I want to use color scales, okay? I want to use color scales. I want to use different colors. Let's say I want to use only 2 colors. Okay, for example, I will select this rule. Okay, now you can see that cells where my numbers are stored, they have some colors. This is very impressive, very interesting, right? So what kind of colors do we have here? So we start from a white color and go to what? We go to green color. But some colors are light green, others are dark green. So colors are changing from white to green, right? But the question is how colors are assigned. If you look at negative numbers or they are white, right? Then they are increasing, becoming a little bit green. Then the numbers increase to 2, color is changing, right? Then we go to what? We go to 5, it becomes green. Then we go to 6, it becomes very green, right? So in such way we can visualize data sets. Or let me type in this way: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, I'll select this range of cells, then conditional formatting, and we'll apply exactly the same rule. Okay. So colors are changing from what? From white to green. It's very beautiful, right? The numbers are increasing, colors are changing. So you can apply another formatting. Actually, we can find some other color schemes. For example, this one or this one. So here we start with green and go to red, right? Small numbers are green. Average numbers are becoming yellow, and large numbers are becoming red. So various rules can be used. So we can define more rules. We can use another colors, which is possible, or we can use data bars. So let's use some data bar. Let's say this one. Okay. You can see a colored bar now, just nearby number. In those places where number is small, bar is short, right? Then the length of the bar is increasing. So this is called bar, okay? Bar. So usually bars or bins are used in histograms. Then when the number is highest, then this is the full length bar here, okay? The longest one. Again, conditional formatting, data bars. So there are different colors, solid colors or gradient fields, or you can define more rules. Also, we have icon sets. Icon sets. We will use given icons here. For example, directional. If you use directional, you can see that 1, 2, 3 are what? Direction is down, right? 4, 5, 6 is to the right, and 8, 9, 10 are direction is up, right? Also, we can use various triangles, actually different 4 arrows or 5 arrows. We can also use shapes, right? Also very interesting to visualize data. For example, for small numbers we use red circles. Average numbers yellow, and then they become green. Or we can use indicators also, which is also possible. We can use ratings, or we can use quarters, or this is like for Wi-Fi, right? So if connection is good, then all these are filled, right? You can define more rules. You can highlight cells, for example, which are containing numbers which, let's say, higher than 4. I can use color. So now cells with numbers higher than 4 are highlighted by color. So you can use very different types of formatting, which is obviously related to visualization here. Let me show you a visualization of a matrix. So here I store a lot of numbers in these cells, right? And I think the size is quite large here until row 302. It means 301 rows and also many columns. So I have filled this with colors based on the values which I have in this matrix. So you know that matrices are also important for engineers, and in the university, engineers, they will definitely study matrices. So here, by applying visualization, actually I used conditional formatting, you can find some patterns here, some interesting patterns in this data set can be found. So you can zoom in and check what happens, right? It's a very interesting visualization. Dear students, thank you for your attention, and please have a good day.